Let's now try another interesting. So you've got a little road here, and you got a car that's run off into the mud. Okay. And so you're trying to pull the car out of the mud. Okay. And so what most people do is they tie a rope to the back of the car and they just pull. Well, the problem is if you pull with a force of 100 pounds, then, in other words, if the force is 100 pounds, that's also the tension. If the force is equal to 50 pounds, then that's also the tension. And so that turns out to be a bit of an issue right there. Okay. And so what we do is we can look at this and say, well, maybe let's look at it a little bit differently. So let's say that you got the road here, you've got the car stuck in the mud right here, and let's say there's a tree or a telephone pole right here. So make sure it's not a busy road, because you don't want to do this as a busy road. And now you tie as tightly as possible a rope between the two. Okay. And then you pull sideways on the rope until you pull it by an angle here. Okay. So let's say that it takes a force of, let's say it takes a force of 40 pounds to pull this an angle of 1 degree. Well, that means if you think about it, if you look at the free body diagram, if this is 1 degree, 1 degree, you're pulling here with a force of 40 pounds. Tension's pulling like that. Tension's pulling like that. So 2t sine of 1 degree equals 40 pounds. So the tension comes out to be basically about 1,150 pounds. Well, that's going to be the force pulling on the car. Now, you don't want to tie it to the bumper because you can tear the bumper of the car off doing that. Okay, now, you don't get something for nothing, because what happens is that after a while, if you're pulling, then that's going to start moving the car a little bit, and now this angle gets bigger. If the angle gets as big as 3 degrees, then 2t sine 3 degrees is going to be equal to 40 pounds. Okay. And so T is going to be now equal to, now it drops to 382 pounds tension. And that might not be enough to move the car much. If it does move the car some, then you make this angle bigger. So if the angle gets up to 4 degrees, then the tension is going to drop even more. So the tension would then be, the tension would now drop to 287 pounds. So the bigger the angle is, then the less the tension is, until eventually it's not going to move the car anymore. So in that case, what you do is you tie this off, okay, pull, move the car a little bit, and then you have to retie it. Pull, move the car a little bit, then retie it and so forth before you can pull the car up to where it's going to start, getting a grip of more solid surface to pull itself out. But anyway, this is kind of a little trick here that people don't normally think about as a way of using these tensions and using equilibrium to actually, again, get a mechanical advantage here in terms of doing what you're trying to do.